Welcome to springlib.
For this problem, we want to find the second derivative using implicit differentiation. So what we're given in this case is sine y plus cosine x equals 1. And the main reason we use implicit differentiation is if we ever have functions in which the x and the y are together, and there's not just one derivative we can take the derivative of both sides because we're given an equation. If we're taking the derivative of an expression, that's different. But since we have this equation here, we'll take the derivative of both sides. When you take the derivative of the right side, it's just going to be 0 since 1 is constant. The left side, however, what we'll end up having is the sine y, the derivative of that will be cosine y, but it'll be times y prime since we're taking the derivative with respect to x. And then it'll just be minus sine x since we're taking the derivative with respect to x. So then what we'll have is we'll add the sine x to this side. We'll divide cosine y over, and what we'll end up getting as a result is that y prime is equal to sine of x over cosine of y. Then we want to find y double prime, so we'll take the derivative of that right there. When we do that, we see that we will use the quotient rule. So y double prime is going to be equal to the low times the derivative of the high. So the denominator times the derivative, so cosine y times the derivative of the numerator. The derivative of the numerator is going to be the cosine of x. We get cosine x times cosine y minus the sine of x times the derivative of the denominator. The derivative of the denominator is going to end up giving us, this will be a negative sine y times y prime. And then all of this is going to be over the denominator squared. So it'll be over cosine squared y. Then when we substitute all this in, what we see is that we have cosine x times cosine y minus sine x. These negatives will cancel right here. So we'll just get plus sine x times sine y. And then we know that this right here is equal to the sine of x over the cosine of y. So that will just make this cubed right here, and it'll make the sine of x squared. So we'll just do this. This will be our final answer for what we have. The only other thing that we would have to do is make sure that the cosine of y is squared as well, because we need to multiply everything through. This would be our final answer for the second derivative.